Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 6 minus 8 is equal to 0, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first we will rewrite this equation as, here you have n to the power of 6 and we will write it as n square and its whole cubed, minus, here we have 2 and we will write it as 2 cubed, and this whole equation is equal to 0. And now in the next step we can use here the nice cubic formula, and you know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So now we can use here this nice cubic formula in the above term, and its above term will be written as, here you have the value of a is n square and the value of b is 2. So we can put the values of a and b in this formula and we get its output in the form of n square minus 2 into n square and its whole square plus ab, and we have a is n square and b is 2 plus b square and b is 2 square, and this whole equation is equals to 0. And now in the next step we can just simplify the terms, and you will get here n squared minus 2 times of n square and its whole square plus 2 times of n square plus 4, and this whole equation is equals to 0. And in the next step you can see here we have two cases. So the first case is, we will take n square minus 2 is equal to 0, and the next step is we can take n square and its whole square plus 2n square plus 4 is equals to 0. So now first I can solve here the first case, and in this case we find the value of n. So now first we can move this minus 2 in the right hand side, and you will get here n squared is equals to 2, and now we can take the square root on both of the sides in this form, and you can see here this 2 and square root are cancelled and you get here n, and here you get plus minus square root of 2. So these are the first two real roots of this equation. So now in order to find the other fourth roots we can just solve here the second case, so, or this case. So in order to solve this case I can first reduce this quadratic equation into the quadratic form, so that here I can just take y is equals to n square. So when you can put y is equal to n square, then you will obtain y squared plus 2y plus 4 is equals to 0. And now in the next step we can apply here the nice quadratic formula in order to solve this quadratic equation, so that here we have a is equal to 1, b is equal to 2, and c is equals to 4, and our quadratic formula is y is equals to minus b plus minus square root of b squared minus 4 times of ac square root over 2 times of a. And now we can put all the values of a, b and c in this formula, and you will get here minus 2 plus minus 2 square, and the 2 square is equals to 4 minus 4 times of ac, and the value of a is 1 and value of c is 4, so 4 times of 4 is equals to 16 over 2 times of a, and the value of a is 1, so 2 times of 1 is equals to 2. And now in the next step we can just simplify the terms here. So we get y is equals to, here you have minus 2 plus minus and 4 minus 16 is equals to minus 12 square root over 2. And now we can write this minus 12 as minus 4 times of 3, so that you will get here minus 2 plus minus 4 times of 3 square root into square root of minus 1 over 2. And here you see that minus 2 plus minus square root of 4 is equals to 2 into square root 3, and minus 1 square root is equals to iota over 2. And now in the next step I can just separate these two terms, and you will get here y is equals to minus 1 plus minus square root 3 of iota. So these are the other two roots, and now we can back substitute the value of y. So here you see that we have y is equal to n square, so now we can back substitute this value here. So when you can put y is equal to n squared, then you will get here n squared is equals to minus 1 plus minus square root of 3 iota. And because in this question we need to solve this problem for the value of n, so that here I can take the square root, again square root on both of the sides. And you can see here this 2 and square root are cancelled by each other, and in the left hand side you will get here n is equals to plus minus square root of minus 1 and plus minus square root of 3 and iota. So in this case you will get here 4 roots. When you can open this plus minus and this plus minus, and you can separate the roots, then you can separately get here the fourth roots in this solution. I can just combine these fourth roots in this way. So finally we have the two roots of the given question are n is equals to plus minus square root 2 iota, and the other four roots are n is equals to plus minus square root of minus 1 plus minus square root of 3 iota. So these are the other fourth roots. So these 4 and 2 are the total sixth root of the given problem, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.